this lesson, we're going to review the application of the payment, IPMT, and principal payment formula. Let's take a look at the formula at a high level before we jump into an example. So there's three different formula that we're going to combine into our analysis here. There's the PMT formula in Excel, which calculates the payment for a loan based on constant payments and a constant interest rate. So that's the blended amount of the payment. Then we have the IPMT formula, and the IPMT formula returns the result of an interest payment for a given period for an investment based on specific periodic constant payments and a constant interest rate when it's applied. And then we have the principal payment formula. So as you can imagine, the PPMT formula calculates a principal payment of a given period for an investment or loan based on specific periodic constant payments and a constant interest rate. So in this example, we're going to combine all three of those. There's the payment, the blended formula, there's the interest payment formula, and there's the principal payment formula. And these are formula that you're going to want to use if you're creating a loan amortization schedule or payment waterfall, or just analyzing loan or investment scenarios in Excel and you want to run the mathematics on it. So let's jump into an example. In our example, on January 1st, 2020, Flexco purchased equipment through a loan for $1 million, and it's payable under a few different options. There's options A, B, and C. The loan options have interest rates which vary between 5 and 10%. Option A is 5%, option B is 8%, and option C is 10%. The loan applicant has decided that they'd like to pursue the loan arrangement under option A and has asked for the loan amortization table. So in order to calculate what the loan amortization schedule is going to look like, we can apply our three formula, the payment, IPMT, and principal payment formula. Let's take a look at the options in greater detail. So in the first option A, we have the loan amount of $1 million, which is consistently applied across all three options. The annual interest rate varies from 5 to 10%. The payments per year is monthly, so 12 payments per year. The interest rate per period is equal to the annual interest rate divided by the number of payments per year, i.e. 12. So in option A, it's 5% divided by 12 equals 0.42%. The number of years of the loan varies. Option A is 6 years, option B is 12 years, and option C is 20 years. The total number of payments, therefore, is the product of the number of years and the number of payments per year. So 72 payments in total for option A, 144 options in option B, 144 payments rather in option B, and 240 payments in total under option C. When we're running the mathematics for interest payments and amortization schedules, we want to be cognizant of whether the payments are occurring at the beginning or the end of the period. 0 is used if the payments are due at the end of the period. In option A, it's due at the beginning of the period. In option B and C, it's due at the end of the period. So let's take a look at our solution here. Let's assume we want to analyze specific periods. So if I put in period 12 in cell E28, that'll be the period in which I want to determine the monthly payment as a blended amount, the interest amount, and the principal amount. And we've calculated that within cells E29, E30, and E31. As you can see, in period 12, which is the 12th month of the loan under the 72 total payment periods, the monthly payment will be $16,038.11. The interest payment will be $3592.98, and the principal will be $12,445.12. If I were to add the interest and principal portion together, I can get the total monthly payment of $16,038.11. And if we were to look at the other loan options, I can perform a similar analysis and see what the payments are in total for a specific period, as well as the interest and principal portions for those periods. So for instance, for option B, I can see in month 11 what the total payment will be. It's $10,824.53. I can see the interest and principal, and I can do the same for option C. Now, the way in which I've set up this formula is that it's contingent on what I put into row 28. So I can switch row 28, for example, in cell E28, I can put in 13, and it'll give me the data for the interest, principal, and total payment. The total payment is fixed, and the interest and principal functions are calculating the amount. I'm going to undo that. And let's take a look at how I calculated each of those amounts. If I open up the formula for cell E29, I can see that we're using the payment formula, which is the blended payment formula. And there's a few syntax that we want to use for this one. First, we have the rate. For the rate, we want to use the rate that's associated with the total number of payments. In this case, there's 72 payments, so it doesn't make sense to use 5% for the rate. That rate of 5% is an annual rate. We want to translate that to a monthly rate because there are 72 payments. Therefore, we use 0.42% for the interest rate per period, and that's essentially equal to the 5% per year divided by 12 months of the year, and that's 0.42. So we put that in for the rate. For the NPER, that's equal to cell E23, and cell E23 is the number of payments. And in this case, in loan option A, it's 72 payments because there's 12 payments per year and it's a 6-year loan. Next in the syntax, we have the present value. And in this case, the present value is negative $1 million. That's the loan amount, and that's consistent across all 3 scenarios. The future value is 0 because the loan will be paid off at the end of the 72nd payment. And the type is equal to 1 because we know that the payment is at the beginning of the period. Next, I can open up the IPMT formula, which generates for us the interest payment associated with the specific period that we're looking up. In this case, again, we're looking at period 12. So we can see that the rate is looking up the rate of 0.42% again. The period, PER, is equal to cell E28, which is 12. And the total number of payments, NPER, is 72, so we're referencing cell E23. And again, the present value is $1 million, future value 0, and the type is 1 because the payments are at the beginning of the period. Next, we're going to take a look at the principal payment formula. If we open up the principal payment formula, we can see the formula syntax. So first we start with the rate again, it's 0.42%. The period is cell E28, which is period 12, which is what we want to look up. The NPER is 72 because there's 72 total payment periods. The present value is negative $1 million. The future value is 0. And the type is 1 because payments occur at the beginning of the period. So that's how each of the payment, interest payment, and principal payment formula work. It's consistent in the way it works across all 3 loan scenarios, options A, B, and C. The only difference is the inputs. But let's take a look at how this can be portrayed in a loan amortization schedule. Because what if you don't want to just look up a specific period? In this case, for option A, we're looking at period 12, and option B, period 11, and option C, period 5. What if we want to see this type of information presented based on a whole table? So we can do that down below, starting in rows 37. Let's do that for option A. So in period 1, there's going to be the first payment because payments are due at the beginning of the period. And we're going to use the payment formula to calculate the amount of the periodic payments. So how much do we need to pay in month 1? Well, we can use equals PMT, and then we can use the rate of 0.42% for the formula syntax for rate. Then the number of periods we're inputting is 72. The present value is $1 million, and future value is 0. And the type is 1 because payments are due at the beginning of the period. Then again, we can use the principal payment formula to calculate the principal amount that's due in period 1. We use the rate of 0.42%. The PER, the period, is 1, so we're referencing cell C39. The number of periods is 72, so we're referencing cell E23. The present value is $1 million. And the future value is 0, and the type is 1. And then if we move on to the interest, we can apply the interest formula. So IPMT, we put in the similar metrics, and we get 0 interest because the loan has not been outstanding for 30 days yet. We can calculate the balance owing and make that equal to the $1 million present value of the loan at the beginning of the term and subtract the principal amount paid to get the balance outstanding at the end of the first period. Then we can calculate the number of payments that are required for periods 2 through 72. We can calculate the amount of principal, interest, and total payment required until the loan is eventually paid off and becomes nil in month 72, as you can see on screen here. In cell G110, the loan balance eventually gets paid off by the 72nd month. So let's take a look at how I've set up the formula so that I can just drag it down and make that work. Well, if we take a look at the periodic payment formula, I've locked the cells, so it's really just referencing the table above, the input metrics under option A. So there's no change there. Again, this is an example where there's static total blended payments, and the loan eventually gets paid off within 72 months, which is at the end of the 6th year. The principal and interest amount, however, vary. There's going to be higher interest earlier on in the loan term, and the interest will diminish on a monthly basis as time progresses and the loan gets paid off. As you can see, for instance, in month 60, the interest is only $843.91. The loan balance is $187,000, and it's significantly less. If I take a look at how I've set up the principal payment formula, I can see that as I scroll down through the periods, I'm continuously referencing the period in question. So, for instance, in cell E42, I'm referencing cell C42, which is the 4th period. And I'm always making reference back to that present value amount, which is the $1 million loan amount. The rest of the inputs are referencing the interest rate, the total number of payments, and whether payments occur at the beginning or the end of the payment period. And in option A, it's at the beginning. For the interest calculation, I run a similar formula using the IPMT Formula. And again, I'm referencing the period in question, in this case, C42, which is payment period 4, and the present value of $1 million. The rest of the metrics that I'm referencing for option A, i.e. the interest rate per period, the total payments, and whether or not the payment is made at the beginning or the end of the period, I'm referencing that as well. And if I drag that down through the formula, I can create this loan amortization schedule, which shows the principal amount, the interest amount, the total payment, and the end of month balance for the loan until it gets paid off. If I want to spot check, I can see that in month 12, it equals what I had previously calculated up in cells E28 through E31. For instance, the total payment is $16,038.11, which agrees to cell D50. The principal payment is $12,445.12, which agrees to my previous calculation in cell E31. And the interest payment is equal to $3,590.98, which agrees to my previous calculation of E30. And the total payment is really just the sum of the principal amount and the interest amount to get me the $16,038.11. So hopefully you see value in using these formula. They're very handy if you're trying to create a loan amortization schedule or an investment schedule and you want to calculate the amount of the principal or interest associated with it. And again, this works in a situation where there are constant payments. And in this case, the constant payment was $16,038.11 because that's the amount that's required in order to pay off the $1 million loan over the 72 months based on the interest rate of 5% per year. Hey guys, thanks for watching this lesson. I hope you enjoyed it. And if you did, I'd really appreciate a like and subscribe from you. And if you want to learn more about Microsoft Excel, check out these videos above. And don't forget to check out our website, commercecurve.com, where we have lots of in-depth finance and accounting courses available with full training workbooks. All of our courses come with complete workbooks of lessons, examples, pre-built financial models, and training video. Hope to see you there.